Hello Techies, welcome back to BiharGeeks. So today we are going to solve a very interesting problem, that is burst balloons. Okay, so this problem is hard. Okay, and what we have to do here, that we are given an array. Okay, this is our array, and we have to find the maximum coin we can collect by bursting the balloon. So as you see that if we are bursting this particular one, so in that case it will be a minimal value. Okay, first we will remove that the minimal value, because whatever the value is doing the multiplication with that, we will get the same value from that. So when we are bursting this particular thing, so we will keep these three values. Okay, so that's why it's multiplying this way. So we are getting from here is 50. After that, we are when we are moving forward, so we will have, after removing this, we will have 358. So next we are targeting if you're targeting like 5, so in that case its neighbor is 3 and 8. So we are multiplying by this. And after that, when we are bursting 1 and 5 both, now the left thing is 3 and 8. So when we are like bursting like the minimal value like 3, so there will be a complementary one, it will be here. So there will be 138. So that value is coming. Now 8 is alone here. So we are just assuming that 1 and 1 is here. So if you multiply by that, we will get. So in this way, we will get a maximum number of coin. We will get it. Same way, if we are seeing this in particular example, first we will burst like 1, or we can do it if we are bursting like 1, so there will be multiplication of 1 multiplied by 1 multiplied by 5. Okay, so this particular one is now gone. Now there will be a plus, and after that there is the left out 5, like same for the 8. So there will be 1 multiplied by 5 multiplied by 1, so we will get it 5. So 5 plus 5, that will be equal to 10. So we will do it, and we will solve it. First we will use a recursion here. Okay, so we will first try to solve this problem using the brute force. Fine. So first we will have a virtual like balloons from the both ends. Like, okay, so we'll keep like and we'll keep the name as new numbers. Okay, and that will be equal to that will be equal to new int, and the length will be nums dot length plus 2, because we are taking two values, है ना? Okay, and now we will initially give some value. Just copy this value. Okay, just paste it, and there will be value of 0, that will be equal to new nums. Okay, new nums dot length minus 1, that will be equal to 1. Fine. Now we need a loop here. Mm, okay. Okay. Int I equal to 0 nums dot length I plus plus. What happened? I plus plus. Okay. Fine. Now we have to do the insertion of the value inside it. So I plus 1 will be equal to nums I inside it. Okay, that's it. Now we will recursively call this particular thing, and we'll keep the name something different. So we will return BRST burst, and inside this we will pass new nums and the starting point and the length. Okay. Command C, and after this we'll keep private int burst, and inside this we'll pass private nums int left, and and we'll have a right. Okay. Now inside this we'll have a base case here. Okay. So we'll keep if the left is greater than if the left is greater than the right. So in that case we'll return directly 0. 0 from here. Okay. Otherwise we'll have end max coin equal to 0 and for. Now we will try to burst each balloons in the range, and we will calculate the maximum score from here. Okay. So we'll have again a loop only. We just copy from here, paste it, and instead of this, we'll just start from left, and let me remove this, and here it will be I. I will be equal to H and I plus plus. And inside this, we'll have end. We'll keep the name as coins, that will be equal to nums ft minus 1. Then we will multiply this, and better to copy this. Command C, command C. Then it will be multiplied by V, where we'll keep only the I. Okay. And next will be the right plus 1. Right plus 1 from here. We get a coin from here. Now we have to check that the coin is maximum or not. So max coin equal to math dot max, and inside this we'll pass that same max coins and comma coin that we are calculating inside it. Okay. And when we are done with that, we just simply return the max points from here. Okay. Let me run this. Okay. Wrong answer. We have started from here, and we have keep it the nums length as 2, and the last value 0, and the first and the last value we are keeping at 1. We have increases the size, and then for Dot length plus 1 and this, and we have started the recursion, then left, right case, then max, then int left equal to right and then point left. This one we forget to add more values. We need to add that post thing. Command C, and here after doing this we have to multiply the remaining thing. So we'll do the plus, and inside this we'll pass that nums, comma 50 left, that starting point, and the I minus 1. Same we have to do for the next case, burst, and inside this we'll pass again the nums, comma I plus 1, and the next thing will be the right. Okay, let me run this. I'm going this way. Okay, it's got accepted. Let me submit this. So this is a truthful solution. Okay, it's taking time. So as you see that the time is getting exceeded because the complexity, if we talk about this, so it's taking like n factorial. So if the size is like 5, so it will be multiplied by 5 multiplied by 4, 3, 2, 1. Okay. So in this way, the complexity, if the size getting increases, so the complexity is also getting increases. So this solution is not very optimized way. Okay. So we have to you like solve this with other approach. So we'll use the concept of DP here. Okay, dynamic programming. We will use it, and we'll try to like reduce the complexity of this. Okay, let me like remove this. Fine, and we will try to solve this by using the DP. Okay, so we need n equal to nonce. Okay, and same we will need int array, and we'll keep the name as new nums, uh, new nums, and that will be equal to new int, and the size will keep at n plus 2. Right, because as you know that if the single value is left, so in that case we'll multiply by the remaining ones, okay, in both sides, while keeping and adding that value. Okay, so same thing we have to do it here. Nums, uh, let me copy this, new number of zero that is equal to new nums n plus 1, both are equal to 1 only. Okay, next will be, there will be a loop for us. We'll keep a loop, and I equal to 0, I is less than the, now we will have a n here. This keyboard is new now and getting difficulty while typing. Hmm, okay, it's committed ni plus plus. Fine. And inside this, new num I plus 1, and that will be equal to nums I. Fine. So this is done now. Now we have to move. We'll keep 2D array. Okay. DP. And keep the name as DP here and equal to new and keep the size same as n plus 2. N plus 2. Fine. Now it's little. We will need a first outer array and then two internal array. Sorry, I'm talking array. Sorry, the loop. So first will be outer one. So for int and its length, that will initially keeping it 1, and the length should not be greater than equal to the n. Okay, and gth plus. Okay, and inside this again we need a loop that will be from incremental from the left side. So int left I, and that will be equal to left, and there will be incremental. Okay, left will be incremental, and inside this we will have int right, right? That will be equal to left plus ngth length minus 1. Okay, so we will have like middle element we will taking, so we'll keep the left and the right, whatever the value is coming from there. Okay, so we need one more loop for this to keep both values. And I equal to left. Okay, and I will be greater than to IHT I plus plus. It's little complex, but it once you get to understand the logic, it's easy only. Okay. Now we have to calculate the point. So we'll keep int point that will equal to uh, that name we have taken a unum. We'll keep the name here unum, and inside this we'll pass left left minus 1. Okay, and then it will be going to multiply. Inside this we'll have only the I, and then again it will going to multiply with the right plus 1, keeping right plus this right plus 1 from here. Now we need other values also, so we'll keep dp left and the I minus 1 okay, and then plus with the dp I plus 1, okay, and the right value. Okay, after doing this whole calculation we will get a dp value. Now dp left and the right, that will be calculated with math dot max, and inside this we'll pass that dp left and right first and the point which we have calculated. Okay, whatever the maximum value from here we will get it, we just simply return it. So after the third one we will return that dp1 and the n from here. So we will take it this initial value this and we have added this one. We have a dp of array, then right, and then we are calculating from whatever the value we have selected and whatever the max value we are taking it, and we just returning it. Okay, we are getting in an error line number 13. AMG. We are getting out of bond. Where here we have taken that I left right equal to I plus plus end point num left minus 1 num I and then right plus 1 mm, left left and right. There left it's not will be n minus length plus 1 n minus length plus 1. Now we are getting wrong answer expected 167 and we are getting the output this. Okay, let us see again. We have started from the length and we took n plus 2 and then 1 and then we have a loop n plus 1 and this, then we have dp, then we took a length of 1 and then equal to length plus plus, then left is equal to 1 and left is greater than left plus plus, and then we took and calculate the left plus length plus 1 and then for I equal to left and I is greater than equal to plus coin we have nums left minus 1 nums I nums right plus 1 then dp left I minus 1 dp I minus 1 right dp left and right dp max left right and the coin, and we just returned it. And I did something wrong. I'm getting the wrong answer. Hmm. Zero n plus 1 and we took this plus 2 for length 2 we're doing n plus 2 then length left from 0 then left equal to n plus 2 minus 1 remove then n plus 2 minus length left plus plus left plus length minus 1 removing and then left I left plus 1, then right, right plus coin left, then I, then right. Okay, multiply, 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 then dp, here left, and again we have I, then dp, I, and then right, dp right, left, max, left, right, and the coin. We are passing it. Now we are getting array out of bond. Control Z. But we have did wrong. Hmm. Yeah. Minus GH minus 1 plus 1. Compile time. Cancel PH. Finally, it's got accepted. So there is an issue of. Okay, finally it's got accepted. Okay, so if we talk about the complexity here, the complexity is n to the power 3 because of this. Okay, but previously it was like a permutation kind of thing where it's taking like 3 factorial or 4 factorial based on the array size. Now it's like little reduced, but still we can work on it. So for today, that's it. Thank you for watching. Bye bye.